Welcome back, viewers. If you're joining us for the first time, on this channel, you suggest what you need assistance with. Learners, it is your channel. The Math Magician will simplify concepts for you. So subscribe, share, and comment. Right. In today's tutorial, we are looking at sequences and series. Remember, this is an AS course, Cambridge AS course. Right. So the first thing is, on sequences and series, we want to define what's a sequence. Now, a sequence is when a set of numbers follows a pattern, and then there is a clear rule of finding the next number. All right. So we'll look at two types of sequences: arithmetic progressions and geometric progressions. So we start with arithmetic progressions. Right. When we are talking of arithmetic progressions, I'm going to start with an example. So I'm going to start, if I start 1, 3, 5, 7, 9, right, and goes on, right. Clearly, there is a rule of finding the next term. How am I getting the next term? I can see here I'm adding 2 each time to get the next term. All right. So when there is a clear rule of getting the next term, it is a sequence, right? So the first type of a sequence is arithmetic progressions, where you're adding a certain term to get the next term. Now, this which you're adding, we call it a common difference. So this is a common difference, and we denote this by D. Right, so the plus 2 is D. Now, how do we get a common difference? So, to get our common difference, D, you go the next term minus the previous term. So this is how you get your common difference. So, in this case here, we'll go, okay, the next term, you can use these first 2 terms or the next consecutive 2 terms. So I can go, this is 3 minus 1, the next minus the previous, you get 2. So your common difference there, D, is equal to 2. Now, we use the letter A to represent the first term. So we use the letter A to represent the first term. So in arithmetic progression is either when you are adding to get the next term, or you are subtracting. So let's see an example where you are subtracting. So I may start 11, and then I can go 10, I can go 9, I can go 8, and so on. Now I'm subtracting 1 to get the next term. Alright, how do I get my common difference? The next term minus the previous term, which is equal to -1. So D is -1 in this case. Alright, and A again is 11. So when you get a next term by either adding or subtracting, we call that an arithmetic progression. Alright, now when you're looking at arithmetic progressions, what is very important is for you to be able to use the formulas. The formulas are given. For you to be able to use the formulas to get the nth term, to get the sum of the first n terms. So in your MF19, the formula booklet given, you are given formulas for UN, which is your nth term. The formula given there is A plus n minus 1D. So this formula is given in your MF19. The other important formula here is the formula for the sum of n terms. So the sum of n terms, which is equal to n over 2 A plus L. L is the last term in the sequence. So this is in case you have the last term. Sometimes you don't have the last term. Another formula given here for the sum of n terms is, so an alternative formula given is for the sum of n terms is n over 2 brackets 2a plus n minus 1d. Right. So these two formulas, the one for the nth term, the one for the sum of n terms, are provided in the MF19. Your only thing here is to apply these formulas in problems involving sequences. So we are going to do examples on arithmetic progression now. This is an easy section, eh? So now looking at examples on arithmetic progressions. Right, the first thing, we line up our formulas here. These formulas are given in the MF19. So So you're given the ninth term of an AP is 8. The first thing is an AP, so the formulas apply. The ninth term is represented by U9. That's the ninth term. And we're told this is equal to 8. The fourth term, so U4 is equal to 18. Alright, so what we want to find is the common difference in the first term. Right, so since we are given the formulas for you, stuff for UN, you are going to look at the first formula here, which goes A, so we don't have the A here, plus N. Now it's U9, so N is 9. So bracket 9 minus 1, D is equal to 8. So that's substituting for the first one. The second one, you are going to substitute again A plus N minus 1, N is 4. So you're going to go 4 minus 1 of D is equal to 18. Now we're going to simplify these. Right, so this gives A plus 8D is equal to 8. The second one is going to give A plus 3D is equal to 18. Now, you have two sets of equations, two unknowns, you're going to solve simultaneously. So I'm going to solve these simultaneously. I'm going to subtract A minus A, 8 minus that gives 5D is equal to 8 minus 18, that's minus 10. Oh, so divide by 5. So D is equal to minus 2. So I found D here. I go back to an equation and find the value of A. So I'm going to go A plus 8 times minus 2 is equal to 8. So A plus, so this is going to give A minus 16 is equal to 8. So A is equal to 16 plus 8, which is going to be equal to 24. So I found my first term, I found my D. So it's only a matter of you using the formulas which are provided in the MF19. Still on examples on arithmetic progressions, you are given that in AP the 8th term is 39. So again, we will write U8 because this is the 8th term and we know this is 39. So this is the first part. And the fourth term is 19. So again, U4 is equal to 19. Find the first term and the sum of the first 12 terms. So again, like what we did in the first one, we are going to look at these two and substitute the formula for UN. So you are going to go A plus N. Now N is 8, so 8 minus 1, this is 7. D is equal to 39. The second one is going to be A plus N is 4, so 4 minus 1, that's 3D equal to 19. And we're going to subtract. So 7 minus 3, that's 4. 4D is equal to, if we subtract, we get 20. So this gives D is equal to 5. So we have D. So from here, I can go A plus 7 by 5 is equal to 39. So A is equal to 39 minus 35, which is going to be equal to 4. So I found A, I found D. Right, so the first term there I found is 4. Now, the sum of the first 12 terms, I go to my formula for the sum. So sum of the first 12 terms is equal to n over 2. So that's 12 over 2, bracket A is 4, so 4 plus n is 12, so 11 times D is 5, so times 5 here. Right, if you do simplify here, you get 378. Alright, so that's your sum of the first 12 terms. So again here, it's just a matter of you substituting in your formulas. For the nth term, for the sum of n terms, and these formulas are given in your MF19. Now, going on to example 3. Now, find the sum of all the odd numbers between 20 and 100. So try to list them down. So you want to say the first odd number there would be 21. So 21, then 23. Then 25, and it goes on until the last one, which is going to be equal to 99. So try to list them down first so that you see a pattern. Oh, I see there's a common difference here. D, the next term minus the previous term. So each time I'm adding 2, and my A is equal to 21. So this is an arithmetic progression. I want to find the sum, but I don't know how many terms there are. So it's either I can use that one. So if, take note here, if you don't know how many terms there are but you have the last term, you can use the nth term, because this can be your nth term and this will help you find n. So I'm going to use this for n, the nth term. So un is equal to, I've got a, so this is 21 plus n minus 1, I don't have n, so n minus 1. My common difference here is 2, but the nth term here is 99. So 99 is equal to 21 plus 2n minus 2 here. Right, so if I take this side, I've got 8, I've got 7. And this is going to be equal to 2n minus 2. So 2n is equal to 80, so n is equal to 40. So I'm going to explain once more. If you do not have n, use the nth term if you have the last term. The last term will be your nth term and then you have n. So now, in our formula, we want the sum. So we want the sum of the first n terms, the first 40 terms, is equal to n over 2. I can use the second formula because I have the last term, which is 99. So I can go, this is 40 over 2 bracket a, the first term is 21, plus the last term, which is 99 here. Alright, so this is basically 20 by, if I add here, I'm going to get 0, I'm going to get 12. So this is, right, let me add here again, 99 and 21. Right. So that's 120. Right. So 120 by 20 here, I'm going to go 120 by 20, which is going to be equal to 2,400. Alright, so I'm going to go over again. You don't have n, but you need n in your sum of n terms. You have the last term. You can use the last term as your nth term, and then that will help you find n. Alright? Our example 4 here, you are given that the first 3 terms of an AP are m minus 3, m plus 1, 5m plus 5. You want to find m. So here what are we saying? We are saying the first term m minus 3, the second term m plus 1, and then the third term 5m plus 5. So these are the first 3 terms. So a, the second term, the third term. Right. To get m here is simple, because remember, to get d, the common difference, you can use these two to say d is equal to the next term minus the previous term, and this is going to be equal to m plus 1 minus m plus 3, which is equal to 4. So you get 4 here. You can do the same using these two terms, because remember you get the same common difference here. So the next term, 5m plus 5, you subtract m plus 1, which is equal to 5m plus 5 minus m minus 1, which gives 4m plus 4. Alright, so this is the same common difference. Therefore, 4m plus 4 is equal to 4, 4m is equal to 0, m is equal to 0. So you just have, you found the common difference here. The common difference here is the same common difference because it's an AP. You equate to get m. Alright, so once we have m, it means our terms are, this is 0. So we have minus 3, we have 1, we have 5. So these are our first terms here. So a is equal to minus 3. The common difference is equal to 4. Right. We want the sum of the first 10 terms. So we go sum of the first 10 terms. We are going to use this formula because we don't have the last term. So n over 2, that's 5. Bracket a is minus 3. So minus 3 plus n is 9. So 9 by the common difference, which is 4 here. Right, so the sum here, you're going to get 150. Alright, so you are given these 3 terms, the same common difference. You equate the common differences, you find your m, and then you find the sum of the first 10 terms. Here, under arithmetic progressions, you are given that the sum of the first n terms. So I will write sum of n terms, I'm given n squared minus 3n. So they have given us their formula for the sum of n terms. Find the 10th term. Right. I've seen questions like this and candidates actually struggling to see, how do I get the other terms? How do I get the first term? How do I get the common difference? It's actually easy. Just go S1, meaning you're substituting n equal to 1 here. So in the formula, S1 is 1 squared minus 3 times 1, which is equal to 1 minus 3, which is minus 2. Now, go S2. S2 is going to be, now you're substituting n equal to 2. 2 squared minus 3 times 2 equal to 4 minus 6. So this is 4 minus 6, which is equal to minus 2. You're going to go S3. S3, you're substituting 3 for n. So this is 3 squared minus 3 times 3, which is equal to 9 minus 9, which is equal to 0. So what do these mean? Now, take note here. If I go S1, the sum of the first term. So ideally, this is the first term. So this is A. So A is minus 2. So if I line up my sequence here, minus 2. Right. So my next term, I don't know my next term, which is my U2. But I know if I add the sum of the two terms is minus 2. So I go minus 2 plus U2 is equal to minus 2. So U2 is equal to 0. So it means this term here is equal to 0. Now, I don't know the next term, which is U3. Right. To get U3, I can add the sum of the three terms must be 0. So if I go minus 2 plus 0 plus U3, I need to get the sum of the three terms is 0. I need to get 0 here. So it means U3 is equal to 2. So it means this term here is equal to 2. And the sequence goes on. I need the 10th term. I'm going to use the formula for the nth term. So I'm going to go U10 is equal to A, which is minus 2 plus N, which is 9 times the common difference. The common difference here was, okay, I don't have the common difference. I can quickly calculate that. 2 minus 0, which is equal to 2. So the common difference here is 2, which is minus 2 plus 18, which is 16. All right, so that's your 10th term. So when you have formula for Sn, you just substitute. These are the sum of first term, which is the first term, the sum of first two terms, which will include that, the sum of first three terms, which will include all that. All right. So these are my examples under arithmetic progressions. We will look at geometric progressions in another tutorial.